Welcome back for another deep dive. This time, we're really going small, getting granular with hydraulic fracturing, zeroing in on proppants.
Proppants.
Yeah, those tiny particles, holding those fractures open, those fractures we make. It's the whole point of fracking, and we've got a lot to get through today. We've got a stack of academic papers, we've got some technical brochures, and we've even got some patent documentation.
Wow.
Yeah, and it's so think of this deep dive as a crash course in proppant evolution, the different types that are out there, and what to consider when you're selecting one, the best one for the job.
It really is fascinating, isn't it? How these seemingly simple materials can really make or break the success of a whole fracking operation.
Right. I mean, I always knew the proppants were important, but digging into this material, the sources for this deep dive, I'm realizing just how much innovation has gone into these little guys.
Right. Yeah, absolutely. The evolution of proppants, it directly mirrors the challenges that the industry has faced over the years in pushing the boundaries of fracking. So, as they go to deeper wells and higher pressures, more complex formations, they've needed uh, more sophisticated proppants.
Okay, so let's go back to the beginning. Early fracking operations, they just use sand.
Exactly. In the late 1940s, early 1950s, sand, that was the go-to proppant.
Just regular sand.
Yeah, and not just any sand. Often it was whatever was readily available nearby, so you can imagine riverbeds and things like that.
But I'm guessing that wasn't ideal.
It worked for a while, but as the industry, moved to these deeper, higher pressure wells, they started seeing the limitations of just using plain old sand. It wasn't strong enough to hold open those fractures, especially under these extreme conditions.
So they needed a more robust proppant.
Exactly. That's when, Ottawa frac sand enters the picture.
Okay.
This is in the mid-1950s.
Mid-50s, okay.
This higher quality sand, and it was sourced from the St. Peter Sandstone Formation, it became kind of the industry standard. And here's a fun fact, I think. The mesh size that became kind of the norm, that 2040, was purely a matter of circumstance.
Right.
It was what those early Ottawa mines were producing. It wasn't necessarily the result of some scientific optimization.
It seems like practicality often drives those early innovations. It's what you have. You make it work.
Absolutely.
Did the industry stick with Ottawa sand?
For a while, but that demand for even stronger proppants, it continued to grow. When fracking moved into these even deeper, higher stress environments, like in the 1970s, a new contender emerged, and that was sintered bauxite. This is an engineered proppant. It's made from corundum primarily, and it offered superior strength compared to just sand, and it quickly became the benchmark for these high-performance proppants.
So sintered bauxite was a game changer.
Absolutely. It paved the way for a whole wave of innovation in proppant technology. Suddenly the industry realized that they could engineer these materials to withstand incredibly harsh conditions downhole. And that's when we started to see resin-coated sand, both curable and pre-cured, to boost strength and control placement.
Okay.
And then there was our zirconia. Ultimately that didn't really pan out. Followed by lightweight ceramics and those intermediate strength proppants, the ISPs.
A lot of trial and error along the way, I imagine.
Definitely. But all of that experimentation, it really led to some major breakthroughs in proppant technology. And despite all these high-tech alternatives, natural sand, especially northern white sand, still dominates the market today.
Really?
Yeah, it accounts for about 90% of all proppants used.
Wait, so after all that innovation, we're back to sand.
Not exactly. Remember Ottawa frac sand?
Yeah.
That name is directly tied to the high-quality northern white sand that's found in the St. Peter Sandstone. The same formation that, kind of revolutionized the industry all those decades ago. This sand, it's the gold standard for a reason.
So what makes northern white sand so special? Does it all come down to geology?
You hit the nail on the head. The geological history of these deposits is fascinating, and it really explains why it's so valuable to the industry. Millions of years ago, these sand grains were part of ancient shorelines and offshore bars. So imagine these vast beaches, stretching along the coast, and they're constantly being sorted and weathered by waves and wind. Over time, that process created the ideal grain size and shape for proppants.
It's incredible to think that these ancient geological processes,
Yeah.
they created the perfect material for a technology that's shaping, our energy landscape today.
It really is remarkable. And it's not just the St. Peter Formation either. We've got
Mhm.
the Jordan and Wanawak formations all contributing to these vast reserves of high quality sand. But these resources, they're finite.
Yeah.
And with the demand for proppants constantly increasing, the industry has started looking elsewhere.
So what's the alternative when those prime sand deposits run out? I've heard of uh, brown sand or Brady sand. Is that a viable option?
That's a great question. Brady sand, primarily sourced from the Hickory Sandstone in Texas, has
Mhm.
become increasingly popular. But there's this misconception out there that the color of the sand, it dictates its quality.
Hmm.
And so, Brady sand, it might be brownish in color, but it's not necessarily inferior to northern white sand.
So the color's a red herring.
Exactly. The differences between Brady sand and northern white sand, they're rooted in their geological origins. Think of Brady sand as a younger, less mature version of northern white sand.
Less mature, meaning.
Well, it has a higher percentage of polycrystalline quartz and it's not as well rounded.
Yeah.
Plus, it tends to have more feldspar, which can create issues with solubility in certain well
So
environments.
it's not just about grabbing any old sand and dumping it down a well.
Not at all. Selecting the right proppant is a complex decision, and with the growing demand for fracking, we're seeing a rise in what's called non-traditional or fit-for-purpose sand. These sources, they might not meet the strict API or ISO specifications for frac sand, but they can still be effective depending on the well conditions and the economics of the project.
So sometimes you need to think outside the sandbox, so to speak.
Exactly, and this highlights an important point.
Yeah.
The quality of a proppant isn't just about the source material, it's also about the processing technology used. Even a top-notch sand deposit can be compromised by poor processing, while a less ideal source can be enhanced with advanced techniques.
So it's a bit like refining crude oil. You can have different grades and qualities depending on how it's processed.
That's a great analogy. And just like with oil refining, the level of processing, it directly impacts the final product's performance and cost.
Okay, so we've got sand, we've got engineered sand, and other alternatives. What else do we need to consider when choosing a proppant? I imagine strength is a big factor.
Strength is crucial, especially in those deeper high-pressure wells. But it's not the only consideration. Density plays a role in how the proppant settles within the fracture. And conductivity, which is how effectively the proppant allows fluids to flow through the fracture, that's vital for long-term well productivity. And of course, we can't forget about
So
cost.
it's balancing act.
Absolutely. There's no one-size-fits-all proppant. Choosing the optimal one involves carefully weighing several factors. The stress environment of the well, the desired fracture conductivity, budget constraints, and even the availability of different proppant types all come into play.
It sounds like you need a PhD in petroleum engineering just to choose the right sand.
Well, it's certainly a specialized field, but that's why resources like Table 11.2 from our research materials are so valuable. It provides a great summary of different proppant types and their key characteristics.
Speaking of valuable resources, our sources also include figure 11.12, which shows long-term conductivity data for various proppants. I have to admit, those graphs were pretty eye-opening.
Yeah, they really highlight how proppant selection can make or break the long-term performance of a well. Choosing the wrong proppant, that could mean leaving valuable resources in the ground, not to mention the economic hit.
So what does the future hold for proppant technology? Will we see even more specialized materials?
That's a great question, and it's one that researchers are actively exploring. One exciting area is the development of designer proppants materials that are tailored to specific well conditions. Imagine being able to analyze the stress, the temperature, and the fluid properties of a particular well and then engineer a proppant with the ideal characteristics to maximize production in that specific environment.
So instead of a one-size-fits-all approach, we're moving towards like custom-made proppants. That sounds like the future of bespoke tailoring, but for fracking.
It really is.
Yeah.
And it's not just about performance. There's also a growing emphasis on sustainability in the proppant industry. With fracking being a resource-intensive process, researchers are looking for ways to minimize the environmental impact of proppant production. So from sourcing materials more responsibly to reducing water usage and waste generation.
It's encouraging to hear that sustainability is a growing focus. After all, responsible energy production needs to consider the environmental impact too.
Absolutely. It's all about finding that balance between maximizing production and minimizing our environmental footprint. And that
Huh.
means looking at the entire life cycle of a proppant from cradle to grave.
Going through all this research, I'm struck by just how diverse the world of proppants is. It's gone way beyond just, simple sand. We've got everything from basic sand to high-tech ceramics, each with unique properties and applications. It's like a toolbox with a specialized tool for every fracking job.
That's a great way to put it. And just like with any toolbox, choosing the right tool is crucial. That's why understanding the nuances of proppant selection is so important. It can make the difference between a successful fracking operation and a costly failure.
Yeah, it really highlights how much we rely on this often overlooked aspect of fracking.
It's a hidden world that most people don't even realize exists.
Right. I mean, who'd have thought that there's, so much science and engineering that goes into choosing the right sand or ceramic particle to pump down a well. It's like we've been taking proppants for granted all this time.
Yeah, it's easy to overlook the small things, until you really consider the impact they have, and then it's quite remarkable.
So before we wrap up this deep dive on proppants, what are some of the key takeaways that you think our listeners should remember?
Well, first and foremost, proppant selection, it's not a one-size-fits-all kind of thing.
Yeah.
It's a complex decision that involves balancing a whole lot of factors,
Right.
from the well conditions and your production goals to your budget considerations and even environmental concerns these days.
It's about finding that sweet spot where performance and cost effectiveness and sustainability, they all kind of align.
Precisely. And that's where knowledge is power, right? The more you understand about the different proppant types out there, their properties, how they interact with the reservoir, the better equipped you'll be to make informed decisions.
We've covered a lot of ground today, from the humble beginnings of, just using sand to the rise of these engineered proppants
Yeah.
and even the potential for custom designed materials in the future.
Yeah. And we touched on the importance of processing technology and the growing focus on sustainability in the industry.
But this is just the tip of the iceberg, really. There's a whole world of proppant science and technology out there waiting to be explored.
And for anyone who wants to dive deeper, table 11.3 from our research materials, that's a great place to start. It lists various proppant suppliers and gives you, access to some real experts in the field.
It's like a directory for all things proppants.
Exactly. So whether you're, an engineer or a geologist or just someone with a curious mind, don't underestimate the fascinating world of these tiny but mighty particles.
They might be small, but they play a huge role in unlocking the energy that powers our world.
Absolutely.
Well, it's been great chatting about proppants with you. I learned a lot, and I hope our listeners did too.
Likewise. Always a pleasure.
Thanks for joining us on this deep dive. We'll catch you next time.